Hello, welcome back. Today we will be talking about linear equations in one variable, and this is chapter 1.2 from algebra and trigonometry, Ron Larson. So to solve an equation in x, we are looking for to find all the values of x for which the equation will be true. And these values are nothing but the solution of the equation. Right, this is the main gist. Whenever they ask to solve for x, this is what we are looking for. Now, keeping this thing in mind, we can also say that equation that is true for every real number in the domain of the variable means of the given variable, that is called identity. Now the words are a little bit confusing. Let's take one example to understand it. For example, if we have x squared minus 16 is equal to x plus 4 and x minus 4. Now this is your given equation, right? This is what it is given. And do you think it is true? Do you think right hand side matches with the left hand side? Yes, it matches with the right hand side and left hand side. They both match. That is why it is an identity. Let's take another example. X over 2x squared. Do you think it matches with 1 over 2x? Yes, it matches, provided x is not equal to 0. So this is called the identity. That means both the equations, they are nothing but one and the same thing. Remember, whenever we have a 0 as the denominator of any number, that is undefined. And we are talking about something else. In this, we are looking for something called asymptote that we will do in other chapter. Now, there is something another type of equation that is called conditional equations. What are they? So, equation that is true for just specific real numbers in the domain of the variable, not all the numbers. That is called a conditional equation because there is a condition that it will be true only for certain values of the real numbers, right? Certain real numbers will be the values of the equation. So that is called conditional equation. Let's take the same example that we took earlier, x squared minus 16. So if we rewrite the same example, x squared minus 16, but this time equal to 0, then we are talking about the conditional equation, because then there is a condition that x is equal to 4 and x is equal to negative 4 are the only values in the domain that will satisfy this particular equation. I will be using these symbol instead of because to speed up the process. So x is equal to 4 and x is equal to negative 4. They are the only values in the domain that will satisfy this particular equation. Remember, this equation is in the form of a squared minus b squared. So whenever we have a condition, that is called a conditional equation. Let's take another example to understand conditional statement a little better. Another example can be 2x plus 4 is equal to 6. So if I solve it, 2x plus 4 is equal to 6, what will be the x value? The x value will be 1. Now, because we have only one specific real number, that is why it is called a conditional equation. There is another type of equation that is called contradiction. So contradictory or contradiction equations. Contradiction equations. So what are they? So in this case, we are looking for equation that is false for every real number in the domain of the given variable. So the emphasis is on false. Nothing is true for every real number. Let's take one example. Let's say 2x minus 4 is equal to 2x plus 1. Do you think any value of x will satisfy this equation? No. Because if you put x is equal to 0, negative 4 is not equal to 1. If you put x is equal to 1, then also both sides, right and left hand side, they will not be equal. So because there is no real value of x which can make this equation true, these type of equations are called contradiction. Right? Because the right hand side and the left hand side, they don't match each other. So another thing, whenever we say something called no solution, we just write, okay, this equation has, there is no solution for this problem. But what exactly is the meaning of no solution, or what exactly is the meaning of infinitely many solution? Let's understand it one by one. So when we say no solution, it means no matter what value of x you substitute in the given equation, the statement will be false. Every single time, no matter what value, x can be negative number, a positive number, but it will always give you the false statement. On the other hand, infinitely many solutions is just the opposite of the, it is just the opposite counterpart for no solution. Because infinitely many solution means no matter what value you substitute for the given variable, the statement will always be true. So at many times we just write no solution, infinitely many solution, without understanding it, what it really means. So for no solution, it will always be false, whatever the value is. For infinitely many solution, whatever the value is, it will always be true. Sometimes it is good idea to understand the why we write certain things in mathematics. Okay, now let's talk about something called linear equation in one variable. You have done it multiple times. Let's understand it from a different perspective. So when we are talking about the linear equation in one variable, what is the standard form of it? So the standard form for the linear equation will be ax plus b is equal to 0, where a and b are real numbers and a is not equal to 0. So this is the basic idea of linear equation in one variable. So let's take one example. So we have 2x minus 4 is equal to 0. If I have to solve it, we know how to solve it. We will get x is equal to 2. Let's take one more example. 5x plus 4 is equal to 3x minus 8. Can I do the inverse operation? Adding and subtracting, multiplying, dividing. We will get the value of x as negative 6. Right? So we can check these answers by plugging the answer back in the original equation to avoid any extraneous solution. So this is how you know how to solve the equation in the one variable. But what will happen when we are talking about the same thing but in terms of the rational equations? So the rational equations, remember we have discussed it in the prerequisite videos. It is in the form of a p over q, right? It is in the form of a fraction. So x over 3 plus 3x over 4 is equal to 2. If I have to solve it, what we are looking for? We have two separate denominators. So let's make a common denominator, because we can add the fraction only and only if we have the same common denominator. And when you are adding the fractions, be careful, you are not adding the denominators. Once you have the common denominator, just add the numerators together. So let's multiply the first fraction with the denominator of the second and the second fraction with the denominator of the first. So it will look something like this. Let's clean this up. So we'll get 4x over 12 plus 9x over 12 is equal to 2. Let's clean it up further. Remember, you are not adding 12. 12 will be written only one time. So 13x over 12 is equal to 2. And then 13x, I can multiply 12 and 2. So 13x is equal to 24. Yeah, I miswrote 24 first. So 13x is equal to 24. So x will give you 24 over 13. I know it is an improper fraction, but we can rewrite it as a mixed number. And whenever we have these type of equations, it is a good idea to check your answers by plugging it back in the original equation so that we can avoid any extraneous solution. I have used the word extraneous a couple of times in this video. What is the meaning of extraneous? Extraneous means a solution that does not satisfy the equation. That is the meaning of extraneous. I have solved one rational problem for you. I want you to try one question on your own. If you want, you can pause this video and try this question first before we jump to the next topic that we need to discuss. So I want you to try this one. Solve 3x over x minus 4 is equal to 5 plus 12 over x minus 4. And don't forget to check for extraneous solution if there is any. Please give it a try. Now, the next topic that we would like to discuss is finding the intercepts. Again, we have discussed about the intercept in the previous video. Let's elaborate a little bit further. So when we are looking for finding the intercept, how to find the x-intercept, how to find the y-intercept. So the process is quite simple. To find the x-intercept, what we do? We put y is equal to 0 and then solve for x. On the other hand, if we have to find out what the y-intercept, then we will put x is equal to 0 and then solve for y. Right? Very simple. Let's take few examples. And with this one example, we will solve for both x-intercept and the y-intercept. So let's take 3x plus 2y is equal to 6. Now to find the x-intercept, what we have to do? We have to put y is equal to 0. So it will be 3x plus 2 times 0 is equal to 6, and then solve for x. If we solve for x, you will get answer as 2. So the coordinate is 2 comma 0, and x-intercept is always in the form of a comma 0. Similarly, we can calculate y-intercept, but instead of putting x is equal to 0, instead of putting y is equal to 0, we will put x is equal to 0. So you will get the coordinate as 0 and 3. Right? Okay, now I want you to try one question on your own and find the x-intercept and the y-intercept on your own. So the question is 5x plus 3y is equal to 15. And I will see you in the next video. Bye for now.